So today, let's find out how to find the arc length and the area of a sector. So this right here in red represents the arc length. And in blue, we have a certain angular measure. So meaning between these two lines, the measurement of the angle in here is going to be 140 degrees. Now it turns out there is a nice relationship between the angle, the radius, and the arc length. It's found via this formula, that the arc length S will be equal to the angle measurement between the two radii in radians multiplied by the value of the radius. Okay? So, in order to find the arc length, we need to know two things. The angle in radians between the two radii, which we know it in degrees, and the radius measure. And we do know the radius measure, it is 3 inches. So basically, if I know this to be 3 inches, and I need to find this then in radians in order to find then my arc length. So the first question is, well, 140 degrees is what in terms of radians? So we can do a nice little conversion, right, to find that out. Remember and recall that pi radians is equal to 180 degrees. Now there's a few ways that you can, remember this relationship. Sometimes people know that 2 pi radians is 360 degrees, and that's totally fine. There's many ways to do it. 1 radian then, therefore, remember pi is a number, right? It's 3.14159, blah, blah, blah. And yes, it's a symbol here, but it's really a number. So in other words, if you had to divide both sides by the value of pi, which is about 3.14, you would find out that 1 radian is about, 57 degrees-ish? Something like that. Okay? Now what I'm going to do when I do my conversion, though, is I'm going to now take my value of degrees. So it's 140 then. 140 degrees. I'll put a little d for degrees. And then we have to multiply it now by this conversion value. All right, we put our degrees on the bottom and our radians on top, and then all I do is I plug in the corresponding values appropriately. Right, so in other words, the 180 degrees goes down there, the pi radians go on the top. Remember, this is really a number. And then all we have to do is calculate. So we're going to do 140 multiplied by pi, or multiplied by 3.14, and then divide that then by 180. And it's 2.44 now. So this is approximately now 2.44 radians. Okay, let me move that on over a little bit. Now, what you might want to do is you might just want to simplify this instead of getting a decimal number. You can simplify this, right? This would be equivalent to 140 pi all over 180. You can then reduce that down by getting rid of the zeros. Right, and then you would have 14 pi over 18, and then you're like, well, doesn't 2 go into that? Yes, it does, right? So this would be then 7 over 9 pi. You can leave it in terms of pi just like this. If you took this and plugged it into your calculator, 7 divided by 9, multiplied by pi, you would come out to 2.44. All right? So now, it depends. I think I'm going to leave it in the exact number so we can get exact values here. All right? So now back to business. So here, we're going to take this value now. This is in radians that I just found, and I'm going to plug it in for my angle. So now I can solve for the arc length. So in other words, this is 7 over 9 pi. Now, no matter what, if you put the pi in the numerator, that's fine. If you put the pi next to it like a multiplication, that's fine too. They both mean the same thing. Multiply that then by the 3 inches. And now if you notice here, you just multiply straight across. 7 times 3 would be 21. This is then 9 times essentially 1 on the bottom. So that's just 9, and then the pi comes along for the ride. But you can reduce this down if you like to a 1 and then a 3, because we're going to have to simplify it in the end. And this works out to then be 7/3 now. 7/3 pi. So that is indeed the arc length. Okay, that's the answer for arc length, and the units here are going to be in terms of inches. If you wanted to find a decimal value, just take your 2.44 and then multiply it by 3. All right, so this works out to be in decimal value. This works out to be about 7.33 radians, okay? So that takes care of that. So that is indeed the arc length, all right? Now what we have to do, so let's erase some of this beautiful work. And now what we're going to have to do is find then the area of the sector, right? So let's just maybe move this on up over there. Now let's find the area of a sector. So now we have to find the area of a sector. So what is a sector? Well, a sector is basically just this area that is cut out by those two radii. All right, I'm going to highlight it. So I'm just going to, this whole area right in here, okay? Now, how do we find that? Well, we can think about it in the following way. So if we know the formula for area of a circle, right? What's the formula for area of a circle? It's simply pi r squared. This is the area of a full circle, meaning this whole thing, okay? If you know, all you need to know to find the area of the whole thing is just the radius. That's it. So this would actually be, I'm going to leave the answer in terms of pi. You plug in your 3 inches there and square it. So your area would then be 9 pi inches. And you can then take 9 and multiply it by 3.14 to find a decimal value if you like, right? But that's essentially the value. That's the exact answer of the area there. But did I shade the whole circle? Did I shade the whole circle here? No. What fraction of the circle did I shade? How could you find that out? What fraction of the circle? Turns out you can do this in a couple of ways. You might know, you might say, well, wait a minute, a full circle, right? Full circle is 360 degrees. And if we shaded only 140 degrees worth, then does that mean that I shaded proportionally 140 over 360? Which would be then 14 over 36, which would then be 7 over 18. Yeah, it would be this fraction, 7 over 18, a little less than half. Well, that makes sense, right? Doesn't it look like less than half? So this is actually the fraction of the circle that you shaded. So wait a minute. If you know the area of a full circle, and now you know that only 7/18 of that circle is actually shaded, what you can do is you can then multiply these two values, right? So I could say that the area, so basically I can create a new formula for you. The area of a sector, okay, is going to be equal to pi r squared, just like we had over here, multiplied now by the degrees that you're given for the sector, which was 140, all divided then by 360. You can use that if you like, if you have degrees. The other alternative form would be, instead of putting this in your parenthesis, if you had, let's say, I don't know, radians instead, you wouldn't plug in then degrees. What you would do inside of this parenthesis then is going to be this. You would then plug in your radian measure, meaning what this measured in radians, and then you would divide that by 2 pi. Okay? So either way, it'll work. All right? But just don't do both. Just choose one. So here, the area of a sector will be equal to, it's simply going to be pi, as we said, times 3 squared, then multiplied now by our 7 over 18, because that's essentially what this reduced down to, right? The 140 over 360. Right, so when we do this, we realize it's 9 pi, then multiplied by 7 over 18. Oh, wait a minute, is that stuff going to cancel? Of course it is, right? The 9 goes away, the 18 becomes a 2, and what are you left with now? You're left with now 7/2 pi. That's now the area of the sector. Okay? So hopefully that all makes sense. And guys, I appreciate it. Thanks so much for tuning in. I look forward to helping you with more problems. We'll see you later.